I'm muted. Good afternoon. How are you guys? Welcome to our webinar today. We're going to be looking at surfaces once more. It looks like a very popular topic, as every time we talk about or we send a survey, you guys pick surfaces. So that's interesting. Okay, let me check the chat really quick and see where my audio is coming from. Testing. Okay. Dun, dun, dun. Let's see the chat. We got audience and speakers. I'm gonna type on the chat. Please, what makes a webinar special and what makes it different from an everyday video is your participation. If you guys have any questions, anything that maybe I'm going over and you'd like me to just go back and see it again, or something in particular you'd like to see about surfaces, type in the chat. That's what it's for. Please make sure that you work with me. So let's get started with this shape. I picked this shape very simple. It's just to demonstrate the different options when it comes to cutting a part. So let's go into a new project, new job. We're gonna do a milling job. Yeah, wizard. We're gonna pick our shape. Okay, there it is. We're gonna do our rectangular shape. We're gonna pick our origin right here, X, Y, Z, perfect. And let's make this, I don't know, like 30, confirm. Okay, so first thing we're gonna do is we're going to do our roughing operation. So we're gonna do 3-axis. We pick our surface here, our solid model. And if you're not familiar, this is new, with our new interface, this is how it looks like. Basically, you got your geometry selection, your feature, your operations, and your backplot. Everything, it's right here, everything that you need to do. So first thing we're going to do is pick our machine strategy. And what we're going to do, we're going to pick roughing. So advanced rough. It's right here. We're going to do, I'm just going to show you the different options. We're going to do equidistance. We're going to do a Z-level finish. And a slice planer, advanced slice planer. Okay, so we got a rough, equidistance, Z-level finish, and advanced planer. So we press next. We're gonna RFIT, so it generates radiuses. If you're not familiar with that, please let me know. And then we have two options, and we're gonna go over, on this webinar, we're gonna go over the difference between the standard UI and the advanced UI. I have a question. This is a very important question for the audience. I see we have a lot of people. Has anybody on the audience worked with the advanced UI yet? Have you guys dwell here, tried to use the advanced UI? This is a really good question because, again, there's a lot of functionality on the advanced UI for 3-axis Pro and 3-axis Premium. If you guys are not looking into this, we actually will have to do a webinar just dedicated to this. Advanced UI, anybody's using it? Please remember, chat with me, right? If anybody's using the advanced UI, I'd like to know. It's just to understand how much and how often is this being used. So we're gonna use our standard UI for this part specifically. We're gonna just do half inch tool. Next, we're going to do we can do a more spiral. Notice that the new interface looks just like what we had before in the middle of the screen, but now when you hover your mouse over the part, you'll see what the feature does. So basically it's pretty much the same. More spiral will follow the shape. We're gonna do a more spiral, 3, perfect. And this is very interesting. As you can see, now we get to see what's happening with the toolpath as we are making changes. So if I change this to an adaptive rough right here and press recompute, I can see how it's gonna look compared to, or if I do an offset out. So as you're working with the system, you have control to see how things are going to work. So I'm gonna change to S-Link. There, we are connections between Toolpath now are S-Link. I can do a full retract. I can do minimize retract. So let's do it direct, minimize. That way, and then we can do between groups, direct. Everything you change, you will be able to see directly on the operation. Okay, now we're gonna go to equidistance. We're gonna use our sets around 3 here. Perfect. Again, right away I can get some toolpath to see how it looks, and this is very cool. I can remove the other just to see how this looks. I can change parameters right there. So the equidistance wouldn't be the best option for this part, to be honest. Even if I change my um, go to the part button and have it cut around, it wouldn't be the best option. As you can see, it's got these drops right here. We're going to use a smaller step over. So let's change step over to 0.5 and compute there. So this will get the job done, but it wouldn't be the best option. So I'm going to show you the Z-level finish. So we're going to use the same tool. Now we're going to use our parameters and we're going to do our step over of 0.5, and we're going to have vertical walls here. Machine vertical walls only, no, adaptive cut. And we're going to have adaptive cut, and then we're going to just have it on the angle ones. This is pretty cool because I'm going to have a smaller step over right here, and that way I can get away with a bigger step over right here. Does that make sense? And I don't know if you guys have used this, but it's pretty awesome because you can have a smaller step over only where you need it, only where there's an angle, but keep the normal step over around the, so let's go one here. We got perfect. Let's check it out. And let's hide our equidistance. And you can see how it's only cutting that area specifically. You see? Then I can remove the trimming and have it go to options and go to part button and then recompute, and there. You can see how it only trims it right here and the step over stays the same right here on this area. Is this clear? Does this make sense? Also, I want to take a minute for you guys to see how different the interface is today. This, it's gonna help you a lot because you don't have to go back and forth. If you wanna change or see what's going on, you are able to change toolpath so quick that you don't have to be redoing things, or it's just completely different to what we were using before. Up to this point, we're good. We understand. Perfect. So now that we were able to see different toolpaths interacting on a simple shape, I'm going to show you. I'm gonna go into SolidWorks and I'm gonna be working on a different part this time. So this time we're gonna be working with this mold here. So we have a couple of inner surfaces, and it's kind of a challenging part because of the number of surfaces it has. So we're gonna go into job from template, we're going to use our template called mold type 1. This is very important because we can have preset toolpaths to be used for different types of parts. In the preset toolpaths, it doesn't have to be perfect for the part. It just has to have the right parameters or the right um, features that you want to use. Okay, so we're picking our geometry, we're defining our stock. There is. We're going to press next. Here's our origin. Okay, it's set up correctly, and we confirm. So first thing we're gonna do, we're going to pick our geometry, which is gonna be this. And then we're going to pick our boundary, which is gonna be tangent here and tangent here. Now, I'm going to teach you a very cool trick about BobCAD. I know we haven't participated that much, but this is a question. Sometimes Toolpath takes too long to compute. And this is because it has to read every surface first and then generate the actual path, do the math before that. So it reads the geometry, then it creates the toolpath. So the tip that I'm gonna give you, I'm going to compute all toolpaths right now, is first compute the toolpath, compute your part with larger stepovers and simple strategies. So don't use the advanced rough or the um, rest machining or any of the high-end operations first. Just create simple toolpath first. Reason I say this is because once you have simple toolpath like the one I just created from my template, when I make changes to this toolpath, the system doesn't have to go through the step of reading the geometry or analyzing the geometry. So what it does, it builds up from the toolpath you created initially. Does that make sense? So when you already created even a simple toolpath, it's going to take less time to recompute when you do more difficult and complex operations. So that's a tip that every BobCAD, and this is something with the new versions because the new versions built on the toolpath that has been created. So it's not like in older versions where you had to actually recreate every toolpath. Just do it like you were starting from scratch every time you recompute it. Here is different. So we're gonna start with the roughing. So for the roughing, we're going to use that tool. Yes, good. I'm going to use our more spiral, and then I'm going to change our leading and lead outs to be ramp, and I'm going to use spiral with a 3-degree approach, and I'm just going to recompute right here. So what you're gonna notice is that the time that it takes to recompute this roughing operation, it's very, very low. It doesn't take that much. And this is a little trick that everybody should know about BobCAD. Now, again, if I want to check out how everything is working out, I can always activate my backplot right away. And I think this is pretty cool because you can just pause it right here, go back to your operation. So we got our roughing done. Now we're going to do our equidistance. That's the right tool, but we're gonna work with a smaller step over. So we're gonna use with step over of 0.5 millimeter, recompute. And again, the time that it's gonna take, it's gonna be it's actually pretty fast. Right here, I'm going to change my linking right here, links to S-link, okay, and recompute. There is. Okay, so I did my S-links. You can see the changes right away. And now we're going to use for our last equidistance a smaller tool, a smaller step over. So this one I want it to be 0.25, and we're going to activate the rest finishing. So there's two ways of doing rest finishing. One is by using an STL. So I don't know if you're aware, but when you're doing simulation, you can save your simulation process as an STL, and then use that STL as the part to determine your rest finishing. In this case, we're going to use tool, but you can get even more precise when you use your STL feature. So we're gonna use that. We're gonna have a smaller step over. We're going to recompute. So again, this is a very large operation, but because we already had toolpath created, it's not gonna take that much. Again, this is V38 working, so you can see that the software is staying very stable. Um, I did a couple of tests with this part beforehand, and it worked very well. So right now we're computing. Okay, so we're done. Okay, so we have a couple of people on the webinar. I'd like to get some questions questions from you if you want to. But also, I have a question. How can we go about eliminating so many unnecessary retractions right here? Because if we go to links inside the system, there's no many options in reality for to define or modify these retractions. So does anybody has an idea or any way that you guys think we can eliminate so many unnecessary retractions? Unnecessary because we already rough and finish the part. So in reality, there's not going to be any material there for us to have to go back up to clearance. So anybody? Okay, let's see the chat from audience and speakers. No? Okay. So here's where the advanced interface is going to make a difference. So we're going to go back to Equidistance 2 right here, and we're going to activate our advanced interface. This opens the advanced interface, and what the advanced interface does for you, again, like I said before, it's going to give you a lot more control over your toolpath. Reason we never had the advanced interface active before in the system is because we wanted to keep BobCAD very, very simple. But around 2 years ago, we made the development decision to allow customers to just use it if they want to. So if you are currently working with surfaces, if you're using or doing 3D work, you have to get familiar with the advanced interface. It's going to make a difference on your shop, and you're going to see why. So first thing, you are able to manage your surfaces better. Okay, you can manage your surface, you can define your offset type, you can create fixtures and determine your fixtures. You have control over the heights of your between your movements. You have better control over your containment curves and how do you want the tool to work within that. Um, you have more control over the gauge checking options, but more importantly, specifically on this case, you have control of how the toolpath is going to behave on different scenarios. What I mean by this is how do I want my toolpath to work when it's coming in? Do every time that is approaching from one position to another, do we have to go from clearance area? In this case, no, because we already remove all the material from that area. So we can actually move from feet distance or from rapid distance if you want to be safer. Okay? How do we want to move from large moves? So when I move from here to here, do I want to go back to clearance area? No, I want to move to feet, distance, perfect. And just making those changes right here, press OK, and recomputing the toolpath, you will see how we're going to eliminate so many retractions. And again, this is something that can be done thanks to the advanced interface. Okay, so does this make sense for now? Okay, let's take a look at our chat. Are we clear? Are we good with this? Okay, looks like we are. So again, this time we did a rest finishing operation and the system is only coming into the areas that we need and it's doing the retractions, it's minimizing the retractions. And this is thanks to the advanced UI inside the system. Okay, so now I'm gonna check out and see if we are able to come in into every area. I think we actually have to use a smaller tool to make sure we come in into everywhere. So I'm just gonna come into my tooling, equidistance tool right here, and let's use 1 and 0.5. Okay, and I think the same step order will work, and we're going to recompute. Again, the trick of making these changes is always have toolpath present. Don't try to do this operation like as the first operation because it's going to take longer to process. But if you had toolpath already preset, it builds up, like I said before, it builds from the prior toolpath. So just do a simple one and then apply the more complex operations to your toolpath as you go, like we're doing today. And again, David has a question. Does the message that an operation needs to be computed only shows in BobCAD for SolidWorks? No, that actually shows in it needs to be shown in both systems. You mean when you modify geometry? You mean when you modify geometry or when you're in the country, David? Okay, we're good. I think we did a good job right here. We're going to close this and then we're going to simulate now. I think we're ready. Let's save. Just make sure. Save as and save. So David, when is this message popping up? When you change geometry? No, I didn't get a message like that. So if I do a change, I'm gonna change my roughing. Let's say here, I'm going to change it to uh, more spiral. Oh, you mean this message right here? So let's check it out because I'm not sure. I see that message, the red message right there. We can try to see it right here. Mhm. Let's try this one. And let's make some changes here. Oh, yep, you do get the same message. need to compute toolpath. So yes, you do get it in V38. There's a new build that they just posted 2 days ago. So David, I I advise you to go back and download it. Maybe that might be the difference. But yes, that message is popping out on B38 as well. Good catch it. I didn't even notice it. So we're gonna do more spiral as we just changed it right here, and then on recomputing. Okay, and now we can simulate. So now that you've been using V38, David, what do you think of it? Do you like it? I'm actually very impressed with it. With V13 and V38, it's been pretty cool to just be able to work and see what's going on. Here we're gonna give it a minute because it's a lot of surfaces, so it takes some time to load into the simulation. And we're gonna see how it looks. So we're gonna start with our roughing. There is. Dun, dun, dun. Looks like it's doing our fine. Let's go with our equidistance. We can move up and see how it's looking. Toolpath, perfect. And then let's go to our pre-finish. And let's get started with those little areas. And as you can see, all the material is gone. So we don't have to be doing retractions all the way to clearance every time we're moving from one operation to another. Just give it a second. Let's pause and move it up here. Oh, it doesn't want to, so let's just go faster. Okay, now we're gonna get closer to the operation, and yeah, I didn't change the tool. It doesn't look like I changed the tool. Let me check my toolpath once more, because it doesn't look like it's doing what it's supposed to. Ah, yeah, I didn't compute. Okay. Okay, let me go back. Okay, patterns, that's why it didn't work. 0.5, and then recompute there. And then we're gonna use the smaller tool, which is gonna be 1 and 0.5 there. Parameters, we're gonna use 0.25, and we're going to use our rest finishing and recompute. The problem is when I computed the toolpath, I didn't press the confirm here. Remember, I'm gonna go back and fix the retractions in the advanced UI. We're gonna go to link, and we're gonna approach from fit distance on both options. Fit distance. And we're going to recompute. So when you're done recomputing and watching the previews, you have to press the little check mark right here so your changes are safe. So that's where I didn't, or just press the finish button as well. So again, with that change, we're going to remove all those unnecessary retractions and keep the tool down. It's just approaching front fit distance when it's necessary. Now we confirm, and now we have rough, finish, and this one. Perfect. Let's save and then simulate. Simulation. Again, this is going to take some time because it needs to read all the surfaces and bring them back into our simulation. And again, I want to make a call to every single person that is watching the webinar, live or offline. Take some time to review the advanced interface. It's going to make a big difference on your programming process and your machining process. You can reduce retractions, you can control the length of your toolpath, you can translate, there's a lot of things you can do from there. So let's just move right here and see how it works. Toolpath is gonna go away. Okay, and now we're gonna get closer to see. Okay, so this looks pretty good. If I want to get a better view of what I'm getting, I can use purification and apply refine. This makes like a little preview of just that area. It looks good. Reset. Let's take a look at here and refine. Yeah, it was able to hit every single area of the surface. Okay. And again, how the software behaves and it works depends a lot on the properties of your computer. If you have your graphics card updated, if everything's looking good, then you're not going to have any problems with the performance. Any questions about what we did right here with this part? Remember, we used the template, we modified the roughing operation, we use two equidistance offset, one equidistance to finish, like you see here, and then one equidistance to do rest finish on the areas that is necessary. Then we use the advanced interface to control the retractions of the toolpath so it didn't go all the way to clearance. Okay, did I open B38? Now let's go and look into some premium toolpaths. There. So one of the things that I wanted to cover on this webinar is the difference between the premium toolpaths and the pro toolpaths and how they interact with different types of surfaces. Okay, so this part is pretty simple. Dun, dun, dun. And we're just going to delete all features and this one too. So we're gonna use 3-axis. We're gonna pick this one and confirm, and we're going to use our planer, advanced planer, or yeah, advanced planer, just to have a cleaner toolpath. Advanced planer, and we're going to press next. Three. Then we're gonna use zigzag We're going to compute. We're going to change the direction here. 90, 0, compute, 90, compute, there. So notice how the surface tends to do this right here. Now, this is just to cut the U shape right here. I can control this and maybe go to 3D stance and see the changes. Maybe, yeah, it doesn't make, maybe I can even use my toolpath editing options to extend the toolpath. I don't know if you guys used this before. So this is something that I think it's pretty awesome. You can extend toolpath, and even though we're coming from inside, you can come from the outside like this. But the difference between this one and the multi-axis, which is premium toolpaths surface, we're going to use flowline, is how it behaves with the surface. So we're going to go this one. We're going to use the same tool. We're going to open our parameters. Our drive surface is going to be the same. We're going to move short side. This is going to be a 3-axis. This is very important. You always have to set it up as 3-axis. Now, if you have premium, it will only give you the option for 3-axis. But if you have 4-axis Pro, you have to let it know that you're working in, or 5-axis Pro, that you're working on 3-axis. And the difference here is you have one, your step over, and you have your cusp height. So this is a different parameter that you do not control on your Pro Toolpaths. Is your cusp height. And the cusp height is the distance of what's left from your material, from your tool passing through on step by step. So you can even control the cusp height that you're gonna leave, giving you more control of the actual result and smoothness of your surface. So we're going to, okay, just compute this one. Now, if we look at both toolpaths for a minute, I'm going to compute and finish, and let's take a look at this. So this is our planar, this is our flow line. Notice how it doesn't do the curvature over here. And even if we change a zigzag to make it, let's go into our parameters. Let's go into, let's do zigzag, and you have the option to extend the toolpath right here. So we're gonna extend it 50% the size of the tool. We're going to press OK. We're going to OK, and then recompute the toolpath. And you can see how the tool, if we go and backplot it, it's coming from the outside and it's not doing that curve that we had before. So it does a better compensation or offset of the tool that it did before when we were using the slice planer. So if we compute and finish both, you can see the difference between them. Can you guys see? Somehow, some reason my tool, let me share my screen again. Share user screen. Can you guys see it again? Okay, so I think it's back. So that's the difference between, it's how it behaves with surfaces. And I'm going to show you another example. So here in demo parts, 3-axis 3D milling, this one. Here's a very good example of the toolpath adapting to a surface better when we use premium. Can you guys see it right here? So instead of having a variable step over or working with a different shape, it's going to always adapt as it's moving up along. So I'm going to show you once more. it a second. So I'm gonna show you. Okay, so here's our equidistance. And let's test this. Here's the equidistance. It does a good job, but again, you have that change in direction. You can use a slice planer, and the way slice planer works through the surface is changing the step over to a smaller step over to adapt. But this is how flow line works. So what's happening here is that it's always the same distance. It's just that the toolpath understands and it raises itself above the other step. So it gives you this type of finishing. And again, you have the control of extending the toolpath. So if we were able to compare, let's just do the rough and pre-finish and the equidistance. Let's use the equidistance. This is the right equidistance, this one. And let's simulate. Dun, dun, dun. And let's just go through it. Bam. Visibility. So here's the Pro Toolpath. Now, again, it does a good work, but it does good work, but you see the changes on direction. And you have these little areas here when we're using the same step over and the same distance, the same tool. Now, let's compare it to our premium toolpath. So I'm going to tell not this one, yes, this one, and let's simulate once more. Let's move it along. Visibility. Okay, so I want us to look at the same area. We're using the same tool, same step over. So when it comes to surfaces like this, they have a big change, like you're seeing it seeing on the screen. There's going to be a big difference using the premium. Can you guys see why or understand? Like the biggest problem, the biggest difference, it's going to be that here we're using the actual surface. We're not working from an STL. So it's working not from the mesh generated in the background, but it's using the actual surface. Now, there's a warning with this. You have to be more conscious about your surfaces. If there's an opening on your surface, if there's an area that is broken, the toolpath will go in there. Sometimes the mesh toolpaths will just clean that up and it will just follow the surface. It in the in when you were talking premium, it will follow the surface. And also you need to be conscious of the normals of your surfaces. So the normals, you activate your normals by pressing the letter N on your on your keyboard. If you press N, you can activate your normals, or if you don't have a keyboard, you can actually go to the view options and change and to see the normals. But if your normals are looking inwards, which we can actually change that in utilities. In utilities, there is an option that reverse normal. If my normal is, if I reverse this normal, and now pick the same geometry and recompute the toolpath. So now it's like it's coming from, let's see if I can activate the, well, in this case, it's not gonna, because we have the shape looking at this, we have the axis looking to the top, but it will affect if it's coming from inwards or from outwards, especially for multi-axis. So you have to be very conscious on the directions of your normals. And you can change this by going to utilities, reverse normal, you click on it, and you need to make sure that your normal is looking to the right direction, because that's going to determine the direction of your cut. Now, any questions about premium toolpaths? We covered this on the prior webinar that I did on premium, but I like to take some time to show this. Premium toolpaths do also have a better way of blending or morph between two surfaces, like you see here. Can you see this is very difficult to accomplish, because let's say the equidistance will follow and will actually blend, but you will always have these direction changes that you can see here and here. But when you use morph between two surfaces, you can see how good of a job the toolpath does when it's following surfaces and when it's morphing between two or three elements. So this, it's going to, again, make it easier for you to follow shapes and have a better finish. Now, are you guys familiar with borrow tools? Barrel tools, I think that's the right way of saying barrel tools. Are you guys familiar with that? Anybody using barrel tools on the audience? Okay, let's check the chat. Anybody using barrel tools? Because I always had that question. How many people are using that technology? Okay, 147. Anybody? Okay, looks like nobody's using barrel tools. So this, basically what barrel tools will do is when you do walls or when you do floors or when you do different areas, there is, okay, Mark, thank you for participating, Mark. So Mark has a barrel tool cutter. So the way you want to use it, first you have to use your premium toolpath, and second, to offset for them correctly, and second, it's the best way I've used them is when we're doing walls. So when we're doing a wall, the best way to do it normally is using the Z level finish. And here we're using our Z level finish. And is, if you look at it, we're using a ball and mill. Now, there's only so much area, surface area, the ball and mill is actually cutting. So there's a lot material that is not touching per pass. So you have to work always with a smaller step over. That's something that's gonna happen with ball and mill. So when you use your borrow tools, so let's go into our tools, tool crib, and then you got your borrow tools. Let's use, notice that you are able to bring different borrow tools into the operation. Let's use, we have this one and this one. Let's use, where is the diameter? I'm going to use this one, the 8. Let's bring it in. Yeah, that one. I'm going to bring it in, recompute, and then I'm going to backplot it. And what's going to happen is the amount of surface that the barrel tool will be able to touch when cutting, it's going to be a lot more. Therefore, we don't have to have the same step over. We can work with a smaller step over and get a better finish. Okay, so that's one of the cool things that barrel tools will do for you. And again, they're part of our premium toolpaths. And yeah, I really recommend looking into that, because again, you're gonna be able to get away with bigger step overs and less machining time and better quality than using an actual Z level finish with a smaller step over. Okay, so thank you so much for being with me on this webinar. We covered a lot today. We were able to see a little bit of 3D surfaces. We looked into Z-level finish and variable step over. The Z-level finish with variable step over, it's pretty cool because you can actually just cut with a smaller step over the areas you need, not everything. So I'm just gonna show that once more. So this, yeah, this is what we saw, being able to do this, where the finish only cuts with smaller step over here, and then the rest is with a bigger step over. So we cover that. We went into premium. We cover our mold, the control you have with the advanced interface, how we can lower our rapid movements and our entries. We looked into B13 and B38 on how comfortable you can make changes to your surface. We saw the trick of always create a basic toolpath first and then work from that basic toolpath. So thank you so much for the people that participated. Thank you for so much for the people that were out in and out of the webinar. I like think we had several people come in and out all the time. So thanks for participating. This webinar will be on our website if you want to revisit it. So always remember all our webinars, bobcatsupport.com. I don't know if you know this. If you go to bobcatsupport.com and you go to training, virtual training schedule right here, all the webinars that we're doing, whether it's Eric, me, or any other technician, you will find them here so you guys can watch it and see them. And the future ones are going to be here also, so you can register for the future ones. So we have one of this every 2 weeks. Remember to sign up for the next one. And if you guys want to, I'd like to get some ideas on what you want to do, because this is the second time we did 3 axis surfaces in less than 2 months, 3 months. So we need some ideas and we need some feedback from you. What do you guys want to learn about? What subjects would you like us to go over on these webinars? If you guys can share some with me, David, Mark, anybody, what would you like to learn next on our webinar? So we can prepare one webinar for you guys. No, not many ideas? Okay, perfect. So we'll send a survey like we always do. Answer your surveys. It's gonna be on social media. It's gonna be in your emails. Once you guys define what you want to learn, we'll prepare our next webinar and we'll see you Wednesday the 26th, just before Thanksgiving. Thank you so much and have an amazing day. Milton. Okay, Dennis, we got one. Okay, we can do a winner in Milton. When was the last one we did for Milton? We did basic lathe techniques, milling machining, programming tricks, tips and tricks. Yeah, it's been a minute since we did Milton. So yeah, that's a good one. We're gonna do Milton next then. Okay, thank you guys and have an amazing day. Thank you for all your participation and I'll see you on the next one. Bye.